So, this thing, whenever you put in an even or odd, or I'm sorry, I'm getting out of steam here. Positive and negative, you're going to get the same y value. Let's say this is equal to 1, right? So positive 1. So cosine doesn't care if you take negative pi, cosine of negative pi, or cosine of positive pi. It's going to give you the same answer. 0 actually is the real reality here. These guys should be there. But it was to make a point. Not a literal point because the points are off. But so it doesn't care whether you give a negative or positive angle in here, because it's going to produce the same dumb value. That's what cosine does. Same thing with secant, because they're reciprocals. So what I'm saying here is that cosine of negative pi over 2 equals cosine of pi over 2. So if you ever see a cosine of a negative angle, right, and everything else is in positive angles, just make this disappear. Cosine doesn't care. It's like honey badger. Okay? Same dumb thing. All right, let's talk about odd functions and their special power. So really the identity here is that cosine...
So evens don't care.
They don't care. They do not care.
They don't give a finna.
Equals this. That's what that identity is, yes? Literally? Okay, good. So let's talk about odd functions. And this could be obviously secant, right? Another one that could work. Okay, so for our odd functions, because they have the special property of being rotatable, here is sine, right? Because they have the special property of being rotatable and being able to map onto themselves, whenever you have a negative angle. So remember, cosine and secant don't care. They just make it go away. This guy says, I don't care, but it has to go on the outside, right? You got to leave. Do that somewhere else. What I do to my kids sometimes when they're acting like buttheads in class, right? You can do that, but just not here. It pulls it out. So whenever you see a negative sign like that, you see this a lot. You can take this thing and pull it inside if you need to. If you see something like that, you can pull it on the outside. So instead of not caring, it just has to send it out of here, right? You can stay, you don't have to go home, but you can't stay here, type of deal, right? Parents ever use that line?
There he was again. Good God.
Right? Negative sign,
I wasn't even here.
the negative, right? You don't have to go home, but you can't stay here. Okay? That's for all these functions. So I could also do this for tangent, right? Because tangent is also an odd function. You don't have to go home, but you can't stay here. Same thing for the reciprocals, cosecant and cotangent. That's what those IDs are meaning. So when you see this, that's pretty easy to memorize, right? We know what our odd ones are, memorize which ones are the odd ones, and which ones are the even ones. And it's pretty easy to remember this. Can't go home, but you don't have to go home, but you can't stay here for our odd ones. Even ones are honey badgers. We're going into overtime, guys. All right. So, sum and difference IDs, double angles. We're not going to worry about those right now. Let's do some proofs, some practice proofs. I've got one for you somewhere. Where's my piece of paper? Nope. Here it is. Thanks, guys. Good assist. All right.
Nope.
You take.
Ooh, yikes. I don't want to use these. These are advanced.
We're advanced pre-com.
These are dealing with sum and difference and double angling.
I'm definitely not advanced.
Yep. So, let's pull some stuff out of here. I know which ones are safe by now, I think. Cece, you're going to read me this, and I'm going to write it on the board, okay?
Cece can speak Cantonese.
Thank you. And hopefully I can translate. Okay. If it has a yes next to it, I want you to read it. Is Dan in this class?
Harris?
Harris, yeah.
No.
Okay, he's in 2D, so we haven't done this.
Oh, Dan Blau.
Got it. Yeah. No, I was asking about Harris.
Well,
5
either
through
way,
10.
we don't have a Dan.
Dan Harris.
Well, no, other Dan. Simmons.
Simmons.
Oh.
5 through 10. Is he in this class?
No.
Not
Okay.
I thought he was in
Got it.
calculus.
No, he's in my class. He was you, right? He was reading the stuff to me, and I couldn't remember if we'd done these problems yet in class or not. We haven't. I did it with 2D, not you guys. So read me number 5. Wherever it says f of x, just give me sine, because that's what it says in the directions, right? So sine of x equals what?
Sorry, my bad.
Sine of x squared plus
Sine squared of x,
sine squared of x plus cosine squared of x
cosine squared of x,
all over cosecant of x.
cosecant of x. Eventually I will omit parentheses because I'm going to get lazy. I'm doing it because I know it's safe. You guys shouldn't. All right, so let's get these to match. Which is the more complicated side?
Right.
This one.
The wrong
I see
side.
Pythagorean ID
It's 1.
equals 1. Let's substitute. Do we see that that's Pythagorean ID, ladies?
Yes.
1 over
Well,
cosecant equals sine.
We're left with this. Cosecant of x. We can flip that because this is a reciprocal. This is equal to sine of x. Look, the sides are matching. We proved it. Ladies, are you paying attention? Because we're going by.
I am, yes.
Okay.
I'm trying.
Do we see? I substituted 1 for that because sine squared x plus cosine squared x equals 1. That's literally an ID, right? Pythag?
Literally.
Okay? 1 over cosecant. Another ID. Reciprocal. It flips. It's a sine. Next one. It has to have a yes next to it, Cece. Otherwise, it's not possible.
Okay.
Sine of x equals what?
Tangent of x over secant of x.
Which side's more complicated?
tangent over secant.
This one. Let's mess with that. Let's get it in terms of sine and cosine, because we need to get to sine, right?
Sine over cosine over,
Tangent is equal to sine over cosine.
and then 1 over cosine.
1 over cosine. This looks awful, but it's not so
Can you
bad.
cross out the cosines?
No,
Wait,
let's
you
not
can
do it that way.
Oh, I
Flip the
got
sucker, multiply.
Make a big bar here, and it won't seem so scary.
big.
So, instead of dividing, we're going to multiply by the reciprocal. So flip this guy. We're going to flip him up here. Cosine is going to go on top. 1's going to go on the bottom. Now we erase this.
Cross out your cosine.
This guy times this guy. This times this guy. Sine of x. Cosine x. Over
C.
cosine x. Notice, we're dividing. Again, if you're not sure about the algebra, if you're not sure you can do this, stop. If you're not sure,
Check.
plug in numbers. 2 for sine of x. Let's do 3 for cosine of x. Does it work?
Yes.
When we cross these out, it equals 2. Let's not cross them out and see if it does the same thing. 6 equals, right? And that's going to equal 2 as well. So our algebra is valid. We can do that. So let's cross these out, and we're left with sine x, which is the goal we have over here. We proved it.
Boom.
Cool.
Go us.
Ayo.
Next one, CC.
Sine of x equals
I text that somewhere.
cosine of x times cotangent. of
Okay,
x.
this is going to be a really dumb question.
Yes.
So as long as you know your IDs, you pretty much can do these.
You can do the basic ones, yes. I'm going to throw some at you that are going to be a little bit crazy because it's more IDs to choose from. But the basic IDs, right, up to odd even,
Yeah.
they kind of solve themselves, right, if you're able to see what's going on. And the ones I give you are not awful.
So as long as I know those, I should be able to do these. Okay.
You need to know sum and difference and double angle and stuff. But yeah, as long as you know those, you should be able to do them, right? You just got to be able to see where they go. So this guy right here, let's work with this side and let's get him in terms of sine and cosine. Cosine's good. Let's leave him alone. So we have cosine x. What's cotangent?
Come on, dude.
Sine.
Oh my goodness.
Got it. Okay, cool. So now let's multiply, because this is really cosine x over 1, isn't it? Multiply. Cosine x times cosine x is cosine squared x over sine x. What are we doing here?
Take the bottom.
What can we do?
We could. We
Did I copy this problem down correctly, CC? Double check. Does it have a no next to it or yes? It has a no next to it, doesn't it?
no next.
Yep, this is impossible.
That's my bad.
It happens. Trig functions are hard. Writing down the problem correctly is like 2/3 of the battle. All right, give me one with a yes next to it.
Cosine times the quantity x minus pi over 2.
Ooh. How do we solve this one? I see something in here, which means we need to look at our identities to see if we can get rid of that, right? We can't keep that going on. We got to get rid of it just to x.
Pi to it equals sine.
Cosine of x minus pi over 2. Where is it? I don't see
Cofunction
cosine x minus pi over 2. I see pi over 2 minus x.
Isn't that can't it be that?
No,
No, it can't.
not when
Never
you're in
mind.
subtraction.
I apologize.
You're
Okay.
gonna go your odd at even.
Odd even.
No.
When there's a negative angle inside here, we can make it positive.
Oh, this is your sum and difference. Because cosine of A plus or minus B.
Kind of, yeah, but it's not because you haven't learned that yet in that book. So unless the book is really, really bad, it wouldn't give you that. No, the answer is odd even functions. When there's a negative in here, you can just get rid of it. And now it's a positive. And this is a negative, right? We switch the signs. You can flip the signs and have no punishment. So this was negative, right? Now it's a positive and this is negative. We can rewrite that as this.
So it is. So it's
Pi
just
over
a sign.
2 minus x.
I was right.
Wait a minute. That's our thing. Wait, no. Did I goof? Did I
No, you're
goof?
good.
No, you're good, you're good.
I'm good. Okay. Which equals sine according to our thing?
Wow. I did math. High five.
Well done, Kylie. Do you see how I did that? Cosine lets you flip the signs, right? It lets you get rid of it. Really, it flips it, makes it positive whenever you want, or makes it negative whenever you want. Doesn't matter. But you have to do it to both sides. You can't just change one and not the other. You got to change both. It's like multiplying by -1.
Probably a firefighter call.
I would have believed it. I would have. A lot of kids do that, man. Or at least they did when I was in high school. I knew a lot of
I
different
think we
kids.
have 1, 2.
All right, one more of these, and then we're going to do the big boys, okay? Sum and difference, double angle IDs, and half angle IDs.
We only got
I
one
have
guess
to go
left
soon.
anyways.
I just picked my sister up.
Do you want more help, or are you just going to do it? Because I could knock this out in probably an hour on another day. Tomorrow I have algebra from 3 to 5:30.
Can we do it? What are we doing during class tomorrow?
During class tomorrow, we're reviewing.
Can we just
Can we
review
just
that?
do
part?
that?
You know what's going to happen is that everybody's not here is going to want me to do what we just did now. At the
Can
beginning.
we-
From the
Can't
beginning.
they just come
Okay,
in Saturday
Cece,
with the party?
Cece,
No,
do
because
you
they're
understand the like?
That's after.
yeah, it'll
Do
be
you
after the final.
understand what's
Oh,
after
that's true,
this?
duh.
What do
Like
you-
the? Do you understand the double angle IDs and the sum